Okay, so in this video, what I will do, I will give some tips which are going to help you when you will implement machine learning model using Google Colab. So the first thing which I want to explain is how you can load your data set in Google Colab. So you can see the first step is loading the data set and how to read the data set. I think you already know how to read, just loading the data set in Google Colab environment. So as you know, in lab third and in lab third, you used iris dataset from the URL. You used the URL in your programming. This week, that is in lab 4, the aim is you should download dataset either from the database, publicly available database, or I already uploaded it. This iris dataset is already available in Brightspace, so you can use Brightspace link to download the dataset. So what I will do, I will demonstrate how you can load and read the dataset using Brightspace. So iris dataset is given here. You can get this dataset if you open this week 4 introduction to machine learning folder. In here you can see lecture, lab and dataset. So dataset is here, iris dataset. So just click here, download. You will get a copy here. Then open your Python program. You can see this folder file. Just click here, then just wait. Then place your mouse in this space, right click, then you will see this upload. You can directly upload, then open. My iris dataset is here, so I will simply download this iris dataset and okay. So iris dataset is here, so I can directly read. So in order to read my dataset, what I will do, I will use my pandas library, pandas pd. So in Panda library, you will see read underscore CSV function. So we use read underscore CSV function to read CSV file. And since this function is in pandas, so I need an object to access the function which is given in this library. So that is the reason pd dot read underscore CSV, and then I'm using my data set. If you would like to place your data set in a folder and then you want to access it, so just the process is the same. So right click on this space, new folder. You can give a name to this folder. Suppose I'm giving a name data, or I can say my data set, or I can say data set, whatever name you want to set for this folder, data set. Then place your mouse pointer to data set, the folder, right click here and then upload. Then upload the data set in the folder. So your data set will be in the folder. So when you will click here, you will be able to see the data set, and then in order to access the data set, you need to specify the path. So here the path is data set slash then this. So data set and then iris data set. So the process is very simple. So what you need to do, you need to simply, let me just quickly repeat what I did. Click here in this file button, then here right click, upload the data set. So in order to upload the data set, let me just delete this file, upload, find the file, the dataset file, and then it is there. If you want to place your dataset in the folder, right click again, new folder, set the name to your folder, for example data, and then you want to load your data in this folder, then upload, and then iris dataset, and then place it. So the process is very simple. And to read the dataset, if you have just uploaded directly here, then you can read like this. in order to read the function, read the CSV file, read underscore CSV is the function. This function belongs in pandas library, and if you want to use this, you can use it with the help of object. So pd is the object for this. So what I'm doing here, pd dot read underscore CSV, and then I'm specifying my CSV file. And once I'm running this, then what will happen? My data set will be loaded in df. So df is my data set. So let me run this. Why it is showing error? Iris pd is not defined, so I need to first run this. Now if I will run my program, it is working fine, because I need to first run this, import the library, then it will work. So this is how you can load your data set in Google Colab, and then you can read it. All right, now let me move back to the next, to my slide. Okay, so loading and reading the data set is done. Now in this week, you are implementing several algorithms. I think almost all the popular algorithms I covered, which fall under supervised learning techniques, like logistic regression, linear discriminant analysis, k-nearest neighbor. I already covered this in my video. Classification and regression tree, Gaussian and naive-bayes classifier, support vector machine, and mixture of linear regression and LDA algorithm, and non-linear, that is all these algorithms together. So these are the algorithms we are intended to implement in lab 4. I will cover all these algorithms one by one in the lecture session, and I will try to cover as many as possible. So in this week lecture session, my plan is to cover k nearest neighbor algorithm and decision tree. I think I have covered decision tree here. No, I think it is, I have not covered decision tree, but I'm covering decision tree. Decision tree is again is also a very popular supervised learning technique, and all these techniques I will cover one by one, if time will allow me to cover, because I need to cover unsupervised reinforcement and some applications in natural language processing and in other areas. Okay, so these are the algorithms we have intended to implement for our program. So if you are going to use all these algorithms or these classifier, you need to import the libraries for all these. So these are the very popular libraries you should you have to implement, you have to import when you are implementing the your model. So you can see load the libraries. So this is for reading CSV file. This is to create plot. This is to create plot. This is for creating valid data set. Valid data set creation. So I already explained what is the meaning of valid data set creation. Data set is given, creating training data set and test data set. So this is for creating the valid data set. This is for cross validation score. This is for n-fold validation. This is for n-fold validation. If you are going to perform n-fold validation, you need to import these libraries. So when you are selecting the model, you need to apply this stratified fold. So it will help you to use the function for n-fold validation. So you can complete 5-fold, 10-fold, 20-fold validation. This is for generating the report of your implemented model. So classification report. When you will generate classification report, you will get several benchmark metrics outcome. Confusion metric. This is to create confusion metrics. Something like this. You will get some values. This is for accuracy score. This is for logistic regression. This is to create decision tree classifier. This is for implementing a KNN classifier. This is for LDA, linear discriminant analysis. This is for Gaussian, and this is for support vector machine. So whatever model you are implementing, According to your model selection, you need to import or you need to load the library in your Python program. If you will not import the library, you will not, your program will show or your program will flag error message. So keep in mind, if you are implementing any or you are planning to implement any classifier, planning to train any classifier, planning to predict or fit any classifier, you need to import or you need to load the appropriate library before giving training to your model. So this is about how to load the libraries or what are the libraries you need, and explanation of these libraries. Now the next thing is how you will create training and test dataset. When you are creating training and test dataset, you are going to split your dataset D in this format, that is test dataset and training dataset. So this is the function. If you are using sklearn, scikit-learn, then sklearn provides or supports a function called as train underscore test underscore split. So this is the function. What is the name of the function? The name of the function is train underscore test underscore split. So this is the function we use to split the data set in as a training data set and test data set. So if you are using this function, you need to import this library, like from sklearn.model selection import train underscore test split, and then you will write like this: xtrain xtest ytrain comma ytest is equal to train underscore test underscore split xy test size is equal to 0.3. What does this mean? 0.3. Why it is 0.3? 0.3 means 70% training data and 30%, 0.3 represents 30% test data. So test size, if 30% is test data, what does it mean? It means that the remaining is training data set. If you are specifying 0.2, 0.2, what does it mean? It means that 0.2 is a test data. It means that 20% for test data. Then remaining will be, that is 80% for training data. So this is the idea. Then the next term which is given here is random state is equal to 1. What does it mean? If you have instances in your data set and feature vector in your data set instance 1 to instance n, they should be divided randomly. It is not like first 80% training data and rest 20% test data. The distribution should be random. It should be properly shuffled and it should be random. And stratify. Stratify is explained here. If you will read, that is the reason I have given some explanation here. So you can see here, dealing with the data set, splitting the data set, 70% training data, 30% test data, because here test data size is 0.3. It represents the data set is divided like 70% training data, 30% test data. The explanation of the function is presented here, train underscore test underscore split function in scikit-learn model selection module. And what it does, it is splitting the data set. In this example, it is 30% test data, 70% training data. So considering, if you are considering iris data set, then there are 150 instances present, that is 150 rows are present. So 70% training data, it means that 105 instances will go in training data set, and remaining 45 will go in instances will be the part of test data set, and they will be divided or randomly. And train underscore test underscore split function already shuffles the training data set internally before splitting. So the instances will be selected randomly. It is not like 150 instances are there starting from instance 1 to instance 150. Let me repeat this step again. So it is not like 105 instances will be the part of training data set. It is not like that. They will, in the training data set, the idea is like first instance, then 10th instance, then let's say 150th instance. It should be randomly selected. Instances will be selected randomly. So this is the idea. And it is given here. So random is underscore state one, what does it mean? We provide a fixed random seed is equal to random underscore state is equal to one for internal pseudo random generation. So there is some criteria I'm applying, have given here for shuffling. We took the advantage of built-in stratification function. Why? In this context, stratification function means that train underscore test split method return training and test subset that have same proportion, so of class label. So when you are selecting, when you are creating training data set and test data set, so you are selecting, for in this case 105 will be instances will go in training data set, whereas 45 instances will go in test data set. So when instances are coming, 105 instances are coming randomly shuffling after applying random shuffling, so it should not be like majority of class labels should be of same type. We are taking full care so that the class label should also be equally distributed in training data set and test data set, so that there should not be any biasness of class label selection. So that is the reason stratify is equal to y is used. And when you will start working on the lab book, you will get a detailed explanation of each and every part of your code, of the code you are implementing. And if anything will be unclear, you can get back to me. So that's all from my side. Thank you very much.